Okay, everybody, welcome to physics. Today we're going to talk about how to use Excel, and part of it's going to be review from before, and then I'm going to kind of show you how to take advantage of the mathematical capabilities of Excel. Okay, so just here, this is some data that we got from this type of lab, and so the first thing you want to do is keep in mind that Excel will put whatever your first row is, or your first column, that'll be your x-axis. And I want your angle number to be on the x-axis. So this would be the angles, this will be the force. Once you have that all highlighted, then you can go to Insert, and then you want to choose a scatter plot, remember? That was not the scatter plot, but here's the scatter plot. And then you choose it without any lines, and then here's your graph of that. But notice it doesn't have anything out here at 90, right? So to get that, so we can, because we need to get out to 90 to see if we're doing it right. And I'll tell you, those cars weigh, approximately 5 newtons. So you click on the dot, right-click it, and add your trend line. And we're going for linear because that's what we're going to use to extrapolate data, is a linear fit. So we can look at this data now, and we see that these are our angles down here. This is the one that we're trying to figure out if it's right. We're kind of calibrating our relationship with this data point. And you can see out at 90, it's showing 8 newtons. So what does that tell you about this relationship? Well, it tells you that's incorrect, right? Because the car should be weighing, around 5 newtons. And depending on your car, I know this car weighed about 5 newtons. That's part of what you have to do in the lab. So what do you do next? Well, this is kind of the part that's really cool that I really want you to latch onto and understand about how good Excel is. So what you're going to want to do, and you can slide this off to the side, this graph, because you're going to eventually print out 4 graphs in your data table. What you're going to do, though, is you're going to click in your next box. Okay, and then you go up to the formula bar, and you push equals. And that means that you're writing a formula for that box. And what we're going to do for this box is we're going to start using our alternatives. Cosine, tangent, sine, and the inverse. So what you would do, like for this, here's where the formulas are. And math and trig is what we're looking for. So here's cosine. See that? And so see, that's in there. So now now it's asking us, what do you want to take the cosine of? And so this is the number over here, because we want to take the cosine of the angle. Do you agree? So whatever box this is, it's A2. That's what you put in there. So it's A2. But one thing I got to tell you is this Excel spreadsheet expects angle measures in form of rads. And so how many rads are in a circle? 2 pi, right? And there's 360 degrees in a circle too, right? So we need to convert our degree angle measurement to a radian or a rad angle measurement. So what you need to do is divide this number. Okay, so you put in your divide bar there. So you put that in. And then there's about 57.3 degrees per rad. And that number is on your lab. And then you should be able to get an answer. So you push OK there. Now look at this. Do you believe that the cosine of 1 is going to be almost 1? Because it's almost as long as the hypotenuse, right? So this makes sense. So we know that we have done the calculation correctly. Now this is the cool part. To finish this, all you do is just slide that down. So you take just the corner of this box, slide it down, and then you have all of your math done for you. So do you want to do it in a calculator? Probably not. So keep in mind now, we're going to make another graph of this, but we need the angle device, or the angle measurements in the x-axis which means I'm going to just copy and paste all these here into this box. And the reason why I'm doing that is because now my angle measurement will be in the X location. So then you just highlight all these again, and you go through and you insert your scatter plot, and you look for your trend line, and you can see that the number down here is the number associated with 90 degrees. So that would be this one. So does our car weigh 18 newtons? No. So this is not the right, that's not the right relationship. So I'm going to ask you to do the other two relationships for the lab, and then you'll determine what the slope means or what it's equal to, and then you will use that as your new formula, because in the end of the lab, I'm going to come to you and I'm going to change your ramp angle, and I'm going to say, okay, you have to predict what speed this car is going to be at the end of the ramp, using your new formula that we talked about, force equals mass times acceleration. So you'll have the force down the ramp, you'll figure out the mass of the car, and then you'll have to use your acceleration and some other kinematic equations to determine what the final velocity is. That's kind of your final test. And then there'll be a little lab write-up to go with that. Any questions? Okay, hopefully that helps you. You can start your lab.